this question, year 12s and year 13s for my A-level math students, we are told or given that the equation kx squared plus 4kx plus 3 is equal to 0, where k is a constant, so just a number, has no real roots. That'll be very important in a second. Okay, prove that k satisfied by this double inequality or this compound inequality, k is bigger than or equal to 0 and less than 3/4. Now, when a quadratic has no real roots, we should be thinking straight away the discriminant part of the quadratic formula, specifically meaning that b squared minus 4ac must be less than 0 for the quadratic to have no real roots, okay? Because this is bit underneath or inside the square root as part of the quadratic formula for solving quadratics, okay? So, I'm going to label my A, B, and C. So A is the coefficient in front of x squared. Okay, so A equals K. B is the coefficient of x. Okay, so 4K. And then C is our constant term. In this case, is plus 3. So C equals plus 3. I'm now going to substitute these three terms into my expression. We're going to have B squared. So that'll be 16K squared. So 4K all squared. I do 4k times 4k, which is 16k squared, minus 4 times a, which is k times 3. So that becomes minus 12k is strictly less than 0. Again, just check your numbers here if you're unsure. So I checked it by summing in all these values into my quadratic expression, you could say, or the discriminant part, okay? What next? Well, I'm not going to do some factorization, so I'm going to factor out a 4k, okay, because I can take a 4k out of both terms. In the bracket, 4k times what makes 16k squared? Well, that'll be 4k, because 4 times 4 makes 16, and k times k makes k squared. Finally, 4k times what makes minus 12k? Nice and easy, that's minus 3, or negative 3, because 4 times minus 3 is minus 12, times it by k, and we get 12k. That's to be less than 0. So our solutions to this quadratic case, so the one that I'm pointing to now, okay, is when 4k equals 0, or when 4k plus 3 equals 0. Okay, so it's when you set each part to be equal to 0, okay. So if I solve each equation separately, we have k is 0 or k is 3/4, okay, from this equation here, okay, or this one here, more like, okay. So what's next? Well, we're now going to sketch our quadratic, okay, in terms of k, to see where the quadratic is below 0, i.e. below the x-axis. Okay, so again, crosses at 0 and 3/4. Again, this is not my perfect drawing, okay, but you can hopefully forgive me. So this is my x-axis, okay. Don't worry too much here about the y-axis here, because that's not too important at this stage. All we need to know is, when is this curve or this parabola or this quadratic below the x-axis? Is below it, sorry, pardon me, in this region here, okay. So between 0 and 3/4. Okay. So yeah, so our inequality is going to be between 3/4 and 0. Including 0. Because when k is 0, then we don't actually have a quadratic. Okay, we actually have plus 3 equals 0, which is not true. Okay. So yeah. So yeah, what technically, yeah, it is actually meant to be less than or equal to 0, but yeah, it should be actually just greater than 0 and 3/4. Okay, so we shouldn't really have that inequality sign. But if it is equal to 0, then I don't actually have a quadratic. So again, that will still be below the x-axis, if that makes sense. Okay. So yeah, I hope that makes sense. Okay, thank you.